Hi guys, this is Mrs. Trosvik down in House 6B. We are going to be on 11.3, estimating area, page 140, whoops, not 3, 145 in your packets. All right, if you looked at the example, I'm not going to go over the example, but we are going to be estimating the area of our shaded figures. In the example, it talks about if you can define where one square is, that will help us figure out how many square units would make up the inside of the shape, and then we can kind of approximate from there the exterior, those pieces where there are missing full squares. Okay, so with that being said, I'm going to do this a couple ways, so bear with me. Since this shape, if I were to have it fully shaded in the length and the width of this shape, I would create an entire rectangle. So with that being said, I'm actually going to find the area of the entire rectangle, and then I'm going to take these pieces away because it's a pretty easy way to solve besides having to count every single little square inside of the shape. You can do that too, and we will do that with some of our shapes, but for this one, it just makes it a lot easier. Okay, so with that being said, if I have the distance of the length of this shape, my distance would be 4. If I did the distance of the width of my shape, we would go 1, 2, 3, 4, 5, 6, 7 units. If this were completely a perfect rectangle, I would solve by multiplying 4 times 7 to get the area of 28 total units. Now, that's only if my shape was this perfect rectangle. But we see that we have gaps here. Those white gaps would be what we're going to take away from that perfect rectangle to approximate the area of this weird looking shape inside of our rectangle. So with that being said, I can count my whole units. I have 1 here, 2 whole square units, and then I have a triangle and a triangle. And if you think about it, this is about half of a square unit, and this is about half of a square unit. So if I have 2 halves, I would really have a whole. So 1 whole between the 2 halves, and then 2 other whole units would leave me with 3 whole units to take away from my big rectangle. Now that would leave me with 28 minus 3, which would give me 25 square units. Now there's a trick to this because they add an additional piece. They say that 1 square unit actually equals 3 centimeters squared. So we actually have to take those square units and multiply them by 3. Now, once we do that, then we have our answer. And if you have 3/4 is the same as 75 cents. So our best answer or our best estimate would be 75 centimeters squared. And remember, we always measure in square units per area. Okay, now the second one I'm going to do a little bit differently. I'm going to actually draw in all of these lines that you guys can't see very well. And then we're going to just kind of pick out all of the full squares that we have, and we'll approximate from there. So I'm going to just start shading in all the full square units that I do see inside my shape. So I have 1. I'm actually going to use a different color so you can see it better. Sorry, guys. I have 1. I have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I have 14 total full squares. Okay, now based off of the last shape, I know that half of a square, if I had a diagonal, would be a half. So I'm going to go back and I'm going to look for those halves. We have a half here, a half here, a half here, 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 and here. These are perfect halves, so I know I would have 1 whole between 2. 2 holes, and 3 holes. So now I have about 3 whole squares. Now I just have to kind of take a peek at all these other pieces. And if you look, these guys are almost perfect squares as well as these guys are almost perfect squares. So for those guys, I'm going to look for the areas of our shape that have maybe a smaller, tinier piece that might fill in that square unit. So if you watch, I have these big guys that are almost a full square, almost a full square. So we have about 2 more, and then you have this little tiny piece and this little tiny piece. So we're going to count this as 1 and this as 1. So there's 2 more there about. And then we have about 3, about 4 more holes just in those pieces. Then if you look at our last little areas, we have, if you kind of put a diagonal there, they look kind of like halves. So I would count this as about a half, about a half, and about a half, and about a half again. So we would have 2 more holes about. Now, I would go back and I would add all of those pieces together, and I would get 14 plus 3 is 17, plus 4 would be 21, plus 2 would be 23. I could have done a quick 10, 4 and 4 is 8, plus 2 is 10, plus 3 would give me the 13, carry my 1, and I would have 20. Either way, we still have 23. Okay, now, with that being said, I'm not done because they add that extra little piece to us. So 1 square really stands for 2 square feet. So I have to take my 23 squares that I have about in my baseball diamond shape, and I'm going to multiply it by 2 feet because I have to double that amount because 1 square really stands for 2 square feet. So instead of 23, I have around 60, or not 60, sorry guys, 3 and 2 is 6, 2 and 2 is 4, so around 46 square feet. Now, the closest number to my estimate would be the best estimate, and the closest number would be 45 feet squared. So that would be the best guess, the best estimate for our beautiful baseball field. Okay, so you have 2 options. You can do a square or a rectangle around your shape and then deduct those pieces, or you can count your whole squares and then your halves and then approximate what's left with all those weird oblong shapes and get an approximate value that way. Either way works for an estimate because with estimating, we are simply just predicting what it could be. It's not a definitive answer. All right, I'm only going to do a couple more with you. So we're going to look at this guy right here. We have a couple of options for this one. We can do a square and deduct those pieces, or you can count the shape within. If I think about putting a square around this, it seems like I would have almost the same amount of units around the shape to fill in my square as in the shape. So for me, I would find it easier to just go inside the shape and start looking for my whole squares. So I'm just going to draw in my lines again, just to make sure I have all of my lines clear and straight inside my shape. And then I'm going to go and I'm going to start approximating my value. So I have 1, 2, 3, 4, 5, 6 fulls, 7, 8, 9, 10, 11, 12. I have 12 full squares inside my shape. So I'm just going to put that guy over there. Then I'm going to go to my halves again. So my halves, I have a half, a half, a half, a half. That gives me 2 holes. Then I have some really wonky looking shapes. These are almost a perfect square, almost a perfect square. We're going to count them as approximately a perfect square. So I'm going to say I have about 4 perfect squares. And then lastly, I'm going to call these guys about halves. So I have about 1, 2, 3, 4 halves, which really equals 2 full square units. Now I'm just going to add those pieces together. I have 12 plus 2 is 14, plus 4 is 18, plus 2 is 20. So I have about 20 units squared inside of my airplane shape. Now, the square equals 2 centimeters on each side. So each square stands for 4 centimeters squared. So which number am I going to multiply by to find the area, and which number am I going to figure out the perimeter of the figure? Okay, so the outside would be similar to what we're doing on the inside, but I'll show you that in a second. Let's start with area because that's where we left off on the last one. About what is the area of this figure to the left? The area of this figure, all I would do is take the 20 and multiply it by what the square unit would be, which is 4 centimeters squared. So 20 times 4 is going to give me about 100 square centimeters inside of our airplane. Now, they told us that each length is 2 centimeters. What are they talking about there? Well, they're saying that the distance down from here to here on one side of the box is 2 centimeters. They are also saying if I were to say the top of the box, that would also be 2 centimeters long. So if I went from here to here, I went 2 centimeters up, 2 centimeters over. So I went a total of 4 centimeters. Now for this shape, we have rounded edges. We're just going to kind of approximate, kind of like we would with any other shape. Now, I am going to start on a flat area so I know where I'm starting. So I'm going to start right here. And I'm going to call this 1 unit. An angle would be about a unit. It's a little bit longer angularly, but this is an estimate. So since it says about what is the perimeter, we're just going to count the diagonal as about 1 unit as well. So I go 2 centimeters, 2 centimeters, another 2 centimeters. I go up about 2 centimeters, and then I go at a diagonal about 2 centimeters. So far I'm at 2, 4, 6, 8, 10 in distance. We know that this side is the same as this side, so realistically, this whole length from here over, up, and at an angle would be about 10 centimeters long. So I'm just going to draw that in, and I know I'll stop at about the same point that I started. Then from here, I have 10, 10. So I have a total of 10 on this side. I have a total of 10 on that side. Now I have 2 here. Not 2. I have 4 here because each is 2. So this is 2, 4, and then we go down and we have 6. So 1, 2, 3 lengths, which are each 2, would really stand for 6 units. So this little L part of our airplane on this side would be 6 units as well. 2, 4, 6 long. The last step is my angle. My angle and my point would be about 2, 4, so 4 more total units. Now I'm just going to add all of them together. 10 and 10 is 20, plus 12 would equal 32, plus 4 more would equal about 36. If I were to approximate about 36, the closest would be to round to 40 centimeters in length, because 36 would round up to 40. All right. Now, with that being said, the next shape, we would have very straight edges, which is easy to approximate your lengths. These guys, you would just have to factor in what are you going to consider them as. This one, you might want to do a box around it because you don't really have that many units left. I would maybe just draw a box around, and both sides would have the same or similar amount. So you would just draw a box around and kind of deduct what's left. Just make sure you pay attention to 1 square unit equaling 9, but each side equals 3. So the distance on each side is 3, but the inside would be 9 square units. Just keep that in mind when you're solving for your perimeter versus your area. Same thing for the last one. Make sure you're paying attention. 1 square unit is really worth 36 square feet. So they're saying one of these boxes is 36 square feet. So find how many boxes you have total and then multiply it by 36 to get your area. If you want, you can count the 1 square distance to figure out your outside perimeter and multiply it by your 6 feet to get your perimeter. All right, guys. Good luck. I want you to finish 5 through 8 And then you need to go on to Edge Elastic and do lesson 4 when you are done. Have a good day. Enjoy geometry. Edge Elastic lesson 4 when you are completed. Bye, guys.